Okay, so today we're going to learn about prime numbers and composite numbers. Does anybody already know what prime numbers are? Prime number is a number that only has factors of 1 in itself. Now, the other day we played the product game, and we found out that the factors are the numbers we multiply together to get a product, right? So the smallest prime number is 2. Let's all take a color one color and circle 2. 1 doesn't count because prime is a number that has factors of 1 in itself. Now what we're going to do is we're going to do either a design or a shading. I think what I'll do is I'll just do a design of all the multiples of 2. Multiples of 2. So you can either shade or color them in. What are multiples of 2? Ah, and what do you notice about all the multiples of 2? They're all what? Even numbers. So that's actually the divisibility rule for 2. Any multiple of 2 is an even number. And one of my students that I was working with found out, oh, this whole entire column of numbers here, these are all even. So you're using one color to color in all the even numbers. Since all the even numbers are multiples of 2, are they prime or are they composite? The multiples of 2 are actually composite, and that's because they have factors of 2, meaning 2 divides evenly into them. And so like 2 times 2 is 4. That makes it a composite number. Okay, so we're filling in all those. And we're realizing, so I used to bike a lot on the 205 bike path. I would bike past this place called Miles Fiberglass and Composites. And it smelled really bad. It smelled toxic. I probably shouldn't say that about them, like that company, but whatever. Anyway, it smelled horrible. And it was because a composite, you think about a composite, it's not pure. Like something that's prime, wood, for example, is just wood. That's all it's made out of. But what is like fiberglass made out of? It's made out of a lot of different substances, a composite. So when you think about the word composite, you have prime and you have composite. Okay, I like the idea of the composite. There we go. Composite has more than one and itself. More factors, I should say. More factors. And prime, I like that. The compost, that's a good one too. I'm a master composter actually. Did you know that? And then prime has only factors of 1 and itself. So now, what's the next prime number that you can see on the board here? Next prime number would be 3, because 3 is only 3 times 1. Those are the only 2 numbers you can multiply together to get 3. So take a different color, circle 3, since 3 is prime, and now we're going to start to shade multiples of 3. What are the multiples of 3? Oh, because multiple means multiply. So 6, 9 gets shaded. What's the next one? 12, then 15, then 18, then 21, then 24, then 27, then 30. Now, you guys learned the divisibility rule for 3. Does anybody remember what the divisibility rule for 3? How do you know if a number is a multiple of 3? Yes? Right, and notice that they start to alternate even, odd, even, odd, even, odd. If you multiply 3 times 7, you get 21, right? An odd number times another odd number, it gives you, it looks like, an odd number. 3 times 9, those are both odd, you get 27. Did you also notice that the sum of the digits, what's 1 plus 2? 3. What's 1 plus 5? 6. What's 1 plus 8? 9. Yes, okay. 2 plus 1. 2 plus 1, 3. 2 plus 4, 6. 2 plus 7, 9. 3 plus 0, 3. 3 plus 3, 6. 3 plus 6, 9. 39. 3 plus 9 is 12. But 1 plus 2 is 3. You see how that starts over again. Okay, what's the next multiple? Does anybody know after 39? These are going higher than your times tables. 42, because 4 plus 2 is 6, right? 45, because 4 plus 5 is 9. What's the next one? 48? 48, 4 plus 8 is 12. 51, 5 plus 1 is 6. And also see these diagonal patterns that are showing up too. Now I know that 54 is 1, 63 is 1, 72 is 1, 81 is 1. I could keep this diagonal going. 57, 5 plus 7 is 12, 6 plus 6 is 12, 7 plus 5 is 12, 8 plus 4 is 12, and 9 plus 3 is 12. Are you getting what I'm doing here? Now over here, 60. 6 plus 0 is 6. 69. 6 plus 9 is 15. 7 plus 8 is 15. 8 plus 7 is 15. 9 plus 6 is 15. Are there any others? Did I miss one? 9 plus 9 is 18. 9 plus 0 is 9. So that's the divisibility rule for 3, and those, all the ones that are shaded with the red are the multiples of 3. Can multiples ever end? No. Multiples go on for infinity because you can keep multiplying. So somebody asked me the question, how do you decide the difference between factor and multiple, right? Karen, you asked that question earlier, right? What's the difference between a factor and a multiple? Multiple means we multiply. Okay, now pick a different color and circle the next prime number. What's the next prime number? It would be 5. 5. And then shade in all the multiples of 5. How do you know something is a multiple of 5? Oh, 5, 10, 15, 20. So how would you describe those numbers? They all end in a 5 or a 0. So that's the divisibility rule for 5. How do I know something is divisible by 5? Because it ends in a 5 or a 0. So that was actually really easy to shade, wasn't it? Okay, now pick your next favorite color, something totally different, and let's circle the next prime number. What's the next prime number? 7. Circle 7. And now we have to know, I don't have a divisibility rule for 7. Sorry about that. I don't know the divisibility. There isn't actually one that I know of. 7 is just like a very odd number. It's odd. And notice that all of the prime numbers after 2 are all what kind of number? They're all odd numbers, yes. So now let's do our 7 times tables. 7 times 2 is 14. So maybe you figure out a different scribble. Okay, that's 7. 7 times 3 is 21. Oh no, my pencil broke. I gotta push, not push so hard. Okay, 7 times 4 is 28. Good. 7 times, what's the next number? 5? 5 is 35. Okay. 7 times 6 is 42. 7 times 7 is 49. There's 49. Now we caught one. 7 times 8 is 56. 7 times 9 is 63. Now, because it's times 9, remember we can also do this hands trick. If I count the seventh finger, 1, 2, 3, 4, 5, 6, 7, and I put down my seventh finger, I have 6 over here, 3 over here, 63. You know all the multiples of 9 add to 9, right? That was from the video. That was from the other video. Okay, how many people learned that on the video? 7 times 10. What's 7 times 10? 70. 7 times 11? Oh, I need my orange. Okay, I'm going to switch it up a little bit. My orange broke. Okay, 7 times 11, 77. 7 times 12 is what? 84. Okay. 7 times 13, 91. Ooh, nice. Good catch. And 7 times 12, do we have it on here? Oh, I mean 14. 14. I can't count. 7 times 14 is 98. Are we right, Mariah? Fact check us. Okay. Now, what's the next prime number? Are you starting to see what's happening here? As we color in the multiples, every number that's shaded is what kind of number? Composite, because it's made up of multiple numbers, right? Every number that's not colored in is a what kind of number? Prime. 11 is prime. Let's do our 11 times tables. Oops, I did the same color as 5. My bad. Yeah, I'll just go darker blue. Okay, where are our 11s? What are our 11 times tables? Everybody knows they're 11s, right? Okay, there we go. I need a different hashtag. Okay, and now all the numbers that are left, 13 times 11, I think we shouldn't have to do our 13 times tables. I think all the rest of these should be prime. I'm pretty sure, right? Because we've already done all the way to 11 times 11. I think it's everything. So everything left, now take a different color. Let's take brown. I'm going to take brown. And we're going to circle 13, 17, 19. What are these numbers here that are left? Yeah, these are the prime numbers. These are not composite. Composite means it's made up of a lot of different things. So these should be all the prime ones left. And that's why it's a sieve, right? It's a sieve, it's a sieve. Sieve of Eratosthenes. This guy, he's like a famous mathematician. Is he Greek, probably? Probably Greek, okay? Anyway, he figured out that if you were to get rid of all the multiples of 2, the multiples of 3, the multiples of 5, the multiples of 7, those multiples are composite. And then what's left are the numbers that are prime. Because everybody always asks me, is there an easy way to find the prime numbers? No, there is not. In fact, you know, you have really smart people trying to crank out finding prime numbers. But this is one way, using the sieve, right? Where just like you did the pasta, you said it's a strainer. The pasta stays in, everything else falls out. What stayed in the sieve were the prime numbers, and the composites went through, right? Okay, we'll stop that for now.